Okay, so moving on to writing polynomials in the form of linear factors. So extending what we talked about previously, now we're going to work backwards, basically. So you'll be given some information about the polynomial, and then you're asked to come up with the actual function. The easier of the two kinds of examples, in my opinion, are when you're asked to just identify the polynomial in factored form. So for example, it might say something like, find the polynomial, I'm going to abbreviate, of degree 3 with zeros, and then it will list some things for you. So let's say 0 is 6 with a multiplicity of 2 and -9. So meaning it has 2 zeros, 6 and -9. The 6 has a multiplicity of 2. So if I'm going to find a polynomial function, so there would be multiple that have these zeros and multiplicities, but we're going to come up with one of them. So if it has a 0 of 6, so if 6 is a 0, then what factor did I set to 0 to solve to get at? So basically, if 6 is a 0, then x minus 6 is a factor, right? Because if I now were working to find the zeros, I would know that if x minus 6 equals 0, then x equals 6. So if -9 is a factor, then x minus -9 or x plus 9 is a factor. So if the 6 has a multiplicity of 2, I would add a 2 exponent to that factor. And then we weren't given any information about the multiplicity for -9, so we can assume that it is just 1. So this would be an example of a polynomial with degree 3, and you'll, with the 0, 6, -9. And you'll notice it'll tell you how to leave your answer. So for most of these with directions like this, it'll just say leave in factored form, which would be exactly what we're looking at. So like I said, that's really all there is to that kind of problem. Now the next kind of example that you'll see, it will say, okay, so for, let's take a polynomial, we'll say h of x is equal to x cubed minus 3x squared minus 4x plus 12. 3 is a 0. And now I want you to express this polynomial h of x as the product of linear factors. All right, so let's think about exactly what this means. Really, what this is asking you to do is taking a polynomial that you may or may not know how to factor. So once we take this, you kind of want to think about in this process what you know about just factors in general. And I think sometimes it's easier to tie it to just what you know about numbers. So for example, if I looked at the long division of 2 into 7, right? 2 goes into 7 3 times. 3 times 2 is 6. I subtract and I get 1. So 1 is my remainder. So this would tell me that 3 is not a factor of 7, or specifically that divisor. 2 is not a factor of 7 because it doesn't divide into 7 evenly. You know, if we say, okay, 2 goes into, let's say, 36. So we say 2 goes into 3 ones, 1 times 2, subtract, we get 1, bring down the 6. 2 goes into 16 8 times, and we get a remainder of 0. So when you get a 0 remainder, that tells us that yes, 2 is a factor of 36. So really, you're being asked to apply that same logic to this h of x polynomial. So really with the polynomial, we want to, if we know that 3 is a 0, so we're basically saying, okay, x cubed minus 3x squared minus 4x plus 12 is equal to, so if 3 is a 0, that means x minus 3 is a factor. So it's equal to x minus 3 times something else. And we want to find that something else. So to do that, we're going to divide x minus 3 into x cubed minus 3x squared minus 4x plus 12. So there's two different ways you can do this division. There's long division, which I'm going to model for you now, and there's synthetic division that I'm also going to show you. So long division always works, we follow the same algorithm we do with numbers. So basically, I'm looking at, okay, x goes into x cubed how many times? Or what times x equals x cubed? And that would be x squared. And then we multiply. So x squared times x equals x cubed. That's what we wanted. X squared times negative 3 is negative 3x squared. Okay, so we're subtracting the x cubed minus 3x squared from itself. So we know that that will be 0. We bring down the negative 4x, and we ask again. So x goes into negative 4x, negative 4 times. So negative 4 times x is equal to negative 4x, and then I'm going to get a constant term when I multiply negative 4 times 3, so I'm going to go ahead and bring down my constant 2, so I have something to subtract it from. So negative 4 times negative 3 is positive 12, so again, when I subtract, I get 0, which is what I wanted, because remember that 0 remainder tells me that x minus 3 is a factor, and I knew that it was. So if I didn't get a 0 remainder, I would know that something went wrong. So basically what I just realized is x minus 3 times x squared minus 4 is how this polynomial factors. Now the catch is I didn't quite answer the question. The question asks me to write this polynomial in linear factors. So this is a linear factor, a degree 1, but this is a quadratic factor. So I want to factor it again. So again, if it factors, then just go ahead and factor it. If it doesn't, then I can set up the long division again. But this one factors. So I know that x squared minus 4 is x minus 2x plus 2. So now I have come to my complete answer. I have rewritten h of x as the product of linear factors. All three of these are linear factors. All right, so as a last piece of this video, I just want to show you how you could have come up with that using synthetic division. So synthetic division works for most of these problems because it only works, you can only use it when your divisor is a linear factor. So when it's a degree 1 polynomial on the outside. So again, when you're looking at the original problem and you're given that 0, we take the 0, just the 3 to the outside, and then for synthetic division, you just list the coefficients on the inside. So in this case, the coefficient of x cubed is 1, the coefficient of x squared is negative 3, then the next one is negative 4, and then 12. If, let's for example just say, you didn't have an x squared term, then you would want to put a placeholder there in the synthetic division to hold the place for anything that would have an x squared. Okay, so to start synthetic division, we bring down the first term, and then we go through this pattern of multiplication. So I'm going to multiply to the number on the outside. So 1 times 3 is 3, And then I list that number in the next column, and then you add columns. So negative 3 plus 3 is 0. And then we do it again. 0 times 3 is 0, and then we add. Negative 4 plus 0 is negative 4. We multiply. Negative 4 times 3 is negative 12, and then we add and get 0. This number, the rightmost number, is always your remainder. So again, we knew we were going to get a 0 remainder. And then this represents the quotient function, which again, this is no x, the constant. This would be x to the 1. The next one would be x to the 2. So I have x squared plus 0x minus 4, which again, I don't need to write the 0x. So I see that that quotient is x squared minus 4. So again, what that tells me is that I can break up h of x to x minus 3. Again, that was given with the original 0. And then the quotient that I found through synthetic division, x squared minus 4, which again, I would then continue to factor as I did up here.